Hi, and welcome to this week's lesson on trigonometry. We're moving on to the sine and cosine rules today, but we've got a few starter questions on rearranging equations. So have a go at these while you're waiting for the session to start. This is a really important skill that comes about in a lot of different areas of maths, particularly ones where you have longer equations or formulae to remember, like the cosine rule, for example, and it can trip a lot of people up, and it's a way where you lose quite a few marks. So it's a good skill to just practice every now and then. So have a go at the questions. Questions 3 to 6 might throw you a little bit. So if you're getting stuck on 3 to 6, don't worry, skip them, try the next ones. All right, I'll just give you a few minutes for those. Just a reminder that you can find the handouts all in advance on my website, which is mrsk'slightbulbmoments.wordpress.com, and you can download them and have a go at any other questions before the session. You can also find all of my previous videos if you wanted to look back on anything, and they're all on there. If you get stuck at any point today, just type a comment in the chat box or under the video if you're watching this after the session, and I'll get back to you as soon as possible. Okay, finish the one you're on. Answers are going to come up in a minute. You will need your calculator for this session, so if you haven't got that, make sure you get it to hand now, and a pencil and paper would be good. Okay, let's put some answers up and I'll go through a few of them. So we have first one, x equals h plus g. Second one, x equals u squared plus d cubed over u minus t. In that one you had to get the x's onto one side and then factorise out of a bracket. Then 3, 4 and 6, I said they're going to be a bit more tricky or they might throw you, and I'll go through one of them in just a moment. 5, 7 and 8, those are the answers there. So there are some quite trickier ones there with them rearranging the subject. I'm not going to go through them all now because that's not what this session is on, but if you do struggle with any of them, do leave me a comment, and I will get back to you, and I could do a quick section on this as a catch-up to explain a few of them if anyone needs it. I am just going to look at question 3 because this is the one that deals with this assuming x does not equal 0 that I've written in brackets. So if we start with this one, I'm just going to do it in blue so you can see what I'm writing. It's got the square root of 3px equals x. So first off, we need to get rid of that square root by squaring both sides. So I end up with 3px equals x squared. Now, what I can do there, and you can only do this if you're told that x does not equal 0, is you can divide by x. So cancel an x on that side and cancel the x squared on that side. So we end up with 3p equals x, or x equals 3p. Now, don't get into the habit of doing that when you see an x squared, because if you do it and you're not told that x doesn't equal 0, then you're ignoring one possible solution. And I'll show you why that is. If we instead rearranged this, so I'll just do that a little bit again there. So we get 3px equals x squared. If we instead change that to x squared minus 3px equals 0, so can you see I've just moved that 3px onto the other side, I can then take out an x and I'm left with x minus 3p equals 0. Okay, factorised. Now if you think about your quadratics, that means one solution is x equals 0 and one solution is x equals 3p. Yeah, thinking about your brackets and factorising quadratics. So we got the one solution of x equals 3p, but because we divided by x, we ignored the possible solution that x could be 0. It's fine in this question because we were told x wasn't 0. But just before you start dividing by x on both sides, just think really carefully about that. Doesn't come up very often in questions, but it might well do. So that's there for you if you need that. All right, I hope that makes sense. Okay, let's get on with our actual content today, and we're going to look at trigonometry. We're going to look at the area of a triangle using sine. We're then going to look at the sine rule and the cosine rule. So first things first with these, this is all non-right angled triangles, because if you've got right angled triangles, you can find the area by doing half base times height. Simple, easy, no need for trigonometry. And you could also just use basic trigonometry to find missing sides and angles like SOHCAHTOA. But this is all concentrating on non-right angled. And we need to make sure we're labelling correctly first. So do you see here, I've got my capital letters for my angles. So capital A, capital B, capital C. And then opposite them, we've got the corresponding lowercase letters for the sides. So opposite angle C, we've got side C. Opposite angle B, side B. Opposite angle A, side A. That is the same labelling for all of these rules. So whenever you have a non-right angled triangle, we label it like this. Now our rule is area equals half AB sine C. There's a proof for that showing you how to get it from half base times height. I'm not going to go over that now. I'm just going to go over 2 examples of how we use it. Now, as I've just kind of said, we use this when we want to find the area of non-right angled triangles, for example, or when we haven't been given the perpendicular height. So sometimes, even with non-right angled triangles, you can find the area if you know the height and the base. But this is when we haven't been given that perpendicular height. All we need to know is the length of 2 sides and the angle between them. Because if you look at my diagram, my rule here is AB sine C. So AB sine C. So we're looking for that pattern of 2 sides and the angle between them. So have a look at these 3 triangles and see if you can spot which ones I could use this rule on. So could I use this rule to find the area of any of those 3 triangles? Should we have a look together? So this first one, if this was C, so always start with your angle, because can you see in my formula I've got a capital C there, which tells me I want my angle to be C. So when you label your angle C. That means this side must be A and this side must be B. Yep, we've got A, B and angle C. We could use the sine rule. Here, let's have a look. Now, the angle I've been given is 30 degrees, so that would be my C. I've got an A, but I don't know this side. Okay, or if I wanted that to be A and the 9 to be B, I'd need to know this angle here, but I don't, I'm just told it's A. So that is not enough information for us to use the sine rule. It has to be 2 sides and the angle between them. Look at this last question here. I've got my 2 sides, so if I call this one A and this one B, I'd need to know this angle, the one between them. Now I don't know it, so you might first think I can't use the rule, but look, we know both the other angles. So actually here, I'm just going to zoom in and show you how we can do this one. We can work out what the missing angle must be. Take them away from 180 and we're left with 33. So that means this angle here is 33 degrees. We can now use our formula. So our formula, I'm just going to write it up here again so you can see it. It's half AB sine C. Sorry, that A stood for area. Write it out in full if you're doing it. So we have got, and you can just type this straight into your calculator, 0.5, or use a fraction if you want to, times 6 times 2 times sine of 33, and press equals, and you get 3.27. Sorry, it's not working. And it's an area we're finding, so it's in centimetres squared, this one. Oh, I don't know why it's not typing. Okay, and that's to 2 decimal places. So it's just showing you how to plug it in. It's just using your formula. They're all multiplied because it's right next to each other. Half times A times B times sine C. Are you okay with that? So that's just the basic application of that formula. You might also be asked to use this working backwards. So I'm going to go over 2 examples now of how we can use this to work backwards. Firstly, we might be told the area and have to work out a missing side. So always start by labelling. Now remember, this is our formula up here. We want sine C, so our angle is C, and then we've got side A and side B. So our area, which in this case is 45, so now I'm just going to substitute all my numbers into this formula, equals 0.5 times A, which is what I don't know, so I'm just going to write A, times B, which is 12, times sine C, and C is 38. So I've just written everything I know in, and I've just left A as my unknown. Now we need to do a bit of rearranging. Now can you see everything on the right hand side is all multiplied together? So to get rid of all of that, I need to divide by it. So that is the same as me saying that A is equal to 45 divided by 0.5 times 12 times sine 38. Can you see what I've done there? So I've just divided by 0.5, I've divided by 12, I've divided by sine 38. So they're on that side. Plug that straight into your calculator and you would get A equals 12.18 centimetres. If you round to 2 decimal places. Okay, so it's just typing it into your formula, rearranging it to find what's missing. Finding an angle is exactly the same, you've just got to work with the sine element a bit more, so we'll go through an example of how to do that. Start off in the exact same fashion of labelling up. So we want our angle to be called C for our formula to work, and then we've got A and B. Doesn't matter what way round A and B go, they're just the sides next to the angle. So my area is 36, so 36 equals half times A, so 10, times B, times sine, and I don't know what that is, I'm going to leave it as E. I'm going to put it in a little bracket there, so I know it's sine of E. Now, we need to do some rearranging. If you can see again, I want to get rid of these 3 bits here. So I'm going to divide by them. So on the left hand side I've actually got 36 divided by 0.5 times 10 times 17. And you see I haven't worked out any of this on my calculator yet. I'd rather get it all in the right format and then just type the last bit in. And I'm just left with sine E on my right hand side. Can we see what we've done there? So we've divided by those 0.5, 10 and 17 terms. Now that, you could plug it into your calculator now and you would get sine E is equal to 0.423, etc. Now, does that look like that could be the angle we're looking for? 0.423. No, unlikely. What you spotted is that is sine E. We just want to find E. So do you remember how you undo sine? We have to do inverse sine. Okay, so you do sine to the -1 of your answer. And type that into your calculator and you would get 25.1 degrees. Okay, it looks much more likely to be the right answer. Fine answer there. Okay, so both very similar processes. It's just if you're finding an angle, you have to remember to do the inverse sine at the end to work out what that angle bit was. All right, super. I'm not going to give you time to do these now, but these are going to be available after the session if you want a bit more practice. On the left, you've got questions practicing finding the area. So that's just working straight forwards with the formula. And then on the right, you've got the working backwards, finding missing lengths or angles. Some of them get trickier there, so do have a go, even if you found those easy. Especially questions like B and D, maybe, where we've got those little lines in there. A little hint. Okay. Pause it now if you want to have a go, because answers are coming up. All right, answers are on the screen. Pause and mark if you need to. Well done. Okay, that's our first rule done. Now we're going to move on to the sine rule. So just have a look at that little diagram and the formula. See if it's coming back to you. Is it ringing any bells? So our labelling is exactly the same. We've got A, B, C's, capitals for angles, lowercase for sides. Now we need pairs of angles and sides, and we've got two versions of the formula. One for finding an angle with the sign A on top, and one for finding a side with the little a on top. So we use this to find a missing side or angle when we have a pair of matching sides or angles. So that's the key to spotting whether it's a sine rule question. Do you see like I've drawn those little yellow arrows in my diagram? That's showing a pair of matching sides or angles. Little a and capital A is a pair. Little b and capital B, that's another pair. Okay. Use the version with angles on the top, so that top formula if you're finding an angle, and vice versa. So can you have a look at these triangles and see which ones you think you'd be able to use the sine rule with? Okay, have a quick look. Alright, should we go through them together? So this first one, we'll have a look if we've got any pairs. We've got this 20, which is opposite of my 10, and then we've got A, which is opposite of my 12. So I've got two pairs. I'm interested in finding one of them out. Yes, we could use sine rule. Alright. In the middle one, I've got a pair. I've got my 30, which is opposite my 9. But I don't have another pair. Can you see that 15 is opposite this empty angle here, which we don't know? And A, the one I want to find, is actually opposite this side, which I don't know. So we don't have enough information to use the sine rule. We don't have two pairs. Okay. And thirdly, let's look at this one. We've got my 20 opposite my 10, which is great. And I've got my 38 opposite my 12. So looking at that, could I use sine rule? You might think, yes, of course. But actually, you know all of those values. They're not the ones we're interested in. Remember, we're looking to try and find this x. So it has to be involved in the pair. So we have to actually have this angle opposite it to be able to find x. But you'll see we have these two angles, so we could use 180 degrees minus those two and find that missing angle. So yes, we could use it, but we need to do a bit of work first in rearranging. So find the missing angle and then use that pair. It doesn't matter which of the other pairs you use. So you could use x and your missing angle and then 20 and 10, or x and your missing angle and 12 and 38. Okay, it doesn't matter which pairs you use, but one of them's got to include the thing you're trying to find out. Okay, let's go through some examples of how this works. So I'm going to do one of each and then give you some practice questions. So we could do finding a side or finding an angle. If we look at this version first, finding a side. Now, I've written the formula out at the top here. And remember, because we're finding a side, I'm going to use the version with the little letters, the sides on top. Now, they are the same formula. They mean exactly the same thing. And you might not have been told to use different versions, but it just helps with your rearranging. If you just try and get it in this format to start with, it makes it a lot easier. So, first things first, we're going to label up. Now, for the sine rule, my labelling up consists of me just drawing my pair lines, really. So I've got a pair. Again, this is that last question we had. So we've got to find out this missing angle, which is 122 degrees. Okay, oh, sorry. 122 degrees. So that's going to be one of my pairs, because I'm trying to find x. And I'm going to choose to use 20 and 10 as my second pair. It really doesn't matter which one you use. You will get the exact same answer. So I'm starting with A on top, little a, so that means my length. So let's start with that x that I'm trying to find out. and that goes over the sine of the angle opposite it, so sine 122. That should be equal to the other pair, so side on top over sine of 20 this time. Now think about rearranging. How am I going to get x on its own? Yeah, I need to times by sine 122, or sine of 122. So this side, my right hand side, is going to look like this instead. 10 times sine 122 over sine 20. Okay with that? So to rearrange, we've just multiplied the right hand side by sine of 122. Type that into your calculator and you get 24.8 centimetres. Always check to make sure it makes sense, so have a little look at your triangle and see whether that seems like a reasonable size for that length. A little hint is that the longest side is always going to be opposite the longest angle, or the largest angle. So our x is opposite the angle 122. That's a lot bigger than the other angles, so we are expecting our length to be a lot bigger than the other lengths, okay, because it's all basically ratios, they're all proportional to each other. Okay, fantastic. Now let's show you how to find an angle. Exactly the same, but remember I'm going to use the formula with the sine of the angle on top rather than the side length on top. So we're going to start off looking at our pairs. This time the pairs are a bit more straightforward. We don't need to do any finding missing angles. We've just got our two pairs. We want sine A on top. So let's start with the angle we're trying to find out. Sine of A, the one we don't know, over 12, because that's its matching length, should be equal to sine of 20 over 10. Now to rearrange, we want sine A on its own, so we have to multiply both sides by 12. So this becomes 12 sine 20 over 10. Now you could type that into your calculator and you'll get the value for sine A. I think I've got that. If you wanted to check yours, you get something like 0.410 ... Remember that's sine A, so you have to do sine to the minus 1 of that. And then you would get a final answer of 24.2 degrees. Which seems more reasonable as a degree. Okay, so exactly the same process, it's just with the angle one we had to do inverse sine at the end because we were finding an angle. Are you okay with that? I quite like the sine rule, it's quite a nice one to work out, and it's spotting it, it's just those pairs, which I think makes it a nice easy one to spot. Okay, these are some practice questions again. I'm not going to give you time to do them now, you can do them after the session as some extra practice to see if you've remembered them. But remember, find those pairs first and then work out whether you're finding an angle or a side. Okay, pause now, answers are coming up. And these are the answers. Mark your work, well done. Super. Okay, let's look at our final rule today. We are storming through this, I hope you're keeping up. There's some tricky rules here, and again, I'm not giving background into them. There's lots of proofs you can do if you're aiming for those top grades. You might want to look at some proofs. I don't know whether your school signs up for Hegarty Maths, but they've got some quite good videos and little quizzes on the proofs, which are quite useful to learn. Right, this is the cosine rule. It's the same labelling as before. This time, ignore the fact that it's got these lines in the middle. I just didn't cross them out from the sine rule. Sorry about that. I'll get rid of it when I upload the version to my website. But these are the formulae underneath. So you've got, again, one format for if you want to find a side and one for finding an angle. Now, they are both the same formulae. It's just that one of them's been rearranged. So you don't need to remember two. I never use the bottom one, I just use the top one and rearrange it. But if you find you're not that confident at rearranging, you might make a mistake there. So you might be someone who actually prefers to learn one rule for a side and one rule for an angle. Okay, we would use the cosine rule to find a missing side or angle when we have three sides and an angle. So I'm going to go through on my diagram here what ones I'm after. So can you see in my formulae, I've got the little letters A, B and C, and I've got capital A. So that means on my diagram, I'm interested in capital A, little b, and little c. So that's all three sides and one angle. So it's not like the sine rule in terms of looking for two pairs. We actually need three sides, one angle. And again, one of those might be missing. It might be the one we're trying to find, but we either have to know or be interested in three sides and an angle. As I've said before, use the version with a squared as the subject if you're finding a side, and cos a as a subject when finding an angle. Sorry, I'm about to sneeze, so if I go quiet. Right, have a little look at these two triangles. See whether you could use cosine rule and which version of the formula you would use. Okay, should we look at this one together? So if we look at the first triangle, we have got an angle. We could call that A. For our formula, we need it to be an A this time. That means we've got A, B and C. Lovely. We could use cosine for that. We're trying to find the angle, so we would use this version here to make it easier. For our next triangle, this is the angle we know, so again we'd call that one A when we're labelling it. That means this would be little a, and these ones either side would be B and C. Remember, it doesn't matter which way round the sides go either side of your angle, but little a must be opposite big A. So again, yes, I could use cosine rule for this one. We're trying to find a side, so we would actually use this top rule there for that second question. Okay? We're going to go through two examples then. I'm basically going to do those triangles and go through them with you before leaving you to do a bit of practice. So firstly, we're going to look at finding a side, and we're going to use the traditional layout of the formula, I suppose. A squared equals b squared plus c squared minus 2bc cos a. You do need to know these formula off by heart. They are easy to learn once you've learned them. I know that's a really silly thing to say, isn't it? How else can I put it? I think they seem tricky to learn at the start, but if you try and actively learn it, and what I mean by that is put a post-it note up somewhere around your house, get someone to test you on it, actually concentrate and look on it. If you've got a little mini whiteboard, test yourself, or a piece of paper, write it out, screw it up if it's wrong, try again. You'll find you actually learn it quite quickly, okay, as soon as you put a bit of effort in. Right, so let's have a go at this. As I said, you always label up first. So we've got A, little a. Now you know your angle's going to be A because look at the formula. Okay, that's the capital they give you. So there's a little bit of a hint. And we could use our B and C. So substitute in A squared. Now I'm actually trying to find X, so I'm going to write X squared because that's my length A. Equals B squared, so that's 6 squared plus C squared, so 4 squared. Minus 2bc cos a. So it's all multiplied together, 2bc cos a. So it's 2 times b, which is 6, times c, which is 4, times cos a. So times cos of 110. Okay, you can just type that all into your calculator. If you don't trust your calculator's BidMaths, it does depend on user error sometimes. You could put this all in brackets so you know that it's definitely doing that bit first before it takes it away. But depending on your calculator model, you should not need to do that. You should just be able to type it in and get an answer of 68.417. Now remember, that is x squared. So to find x, you have to square root it. Don't forget that last little step. And we get 8.27 centimetres to 2dp. That's why it's always worth checking your answers, because if you look back at your triangle, 68 centimetres seems ridiculously long for that side, even if you are expecting it to be the longest angle. So square root it, and 8.27 centimetres sounds a lot better. Okay, so nice and straightforward if you use that format and you're trying to find a side. Now, trying to find an angle, I'm going to do this one slightly differently. At the top there, you can see I've written the formula for finding the angle. Cos A equals B squared plus C squared minus A squared over 2BC. you can just plug it all into that, and then remember to do inverse cos at the end, because that will give you cos A. You need to find A. So just like we've done earlier on, but you might not be someone that's learnt both formulae. If you're like me, you'll use the other one and just rearrange. So I'm just going to show you using the other one. But remember, you can just plug it into that formula if you like. But I'm going to use this one over here. Mainly because I just learnt one formula and that's all I did, and I just rearranged it. I found it easier that way. So completely up to you. Now we've got to label first. Again, this is my capital A because that's my angle. So that makes that little a, little b, little c. So a squared, so that's going to be 16 squared equals b squared, which is 32 squared, plus c squared, minus 2 lots of b times c times cos of a. I don't know a, so I'm just going to write an x there. Alright, now we're trying to get this bit isolated on its own. It's all a little bit nasty. Because we've got a negative in that, I would suggest straight away just taking the whole of this bit over to the other side. Because we've got, it's easier to see in the formula up here, minus 2bc cos A. So let's add 2bc cos A. So on this side I end up with 16 squared plus 2 times 32 times 40 times cos of x equals, and I've still got on this side 32 squared plus 40 squared. Okay. Now I've got two terms here. I've got 16 squared plus 2 times 32 times 40 times cos x. So let's take away 16 squared. So I'm still left with 2 times 32 times 40 times cos x, and that should equal 32 squared plus 40 squared minus 16 squared. Alright, so I'm getting there. I'm getting closer to having just cos x on its own and it being positive. Now I've got to get rid of all these multiplies. So we're going to divide by all of them, and I'm going to be just left with cos of x equals, oh sorry, that's where my stylus, I'm going to move up the page, it's a bit better there, equals 32 squared plus 40 squared minus 16 squared all over 2 times 32 times 40. Oh, come on. Right, got there at the end. So you can see there's a lot of rearranging to this step. And actually, if I zoom back out, can you see that is exactly our formula in the top right that we've learnt for finding an angle? Cos A equals b squared plus c squared minus a squared over 2 times b times c. So all we've done is either you learn that formula and you get straight to this stage, or you just learn the one formula and you have to do this rearranging step. But you can see if you're not that confident with rearranging, there's a lot of ways that bit could go wrong. Oh, sorry about that. Just going to zoom back out there. Okay. Plug that into your calculator. That will give you cos x. Remember, you need to do inverse cos of x. And you would eventually get that x equals 22.3 degrees. Again, check that's reasonable looking at your diagram. And you're expecting x to be quite small because it's opposite the smallest side. So it's going to be the smallest angle of the triangle. Okay, so again, you've got two choices. Learn the formula if you just want to go straight to this last bit and plug it into your calculator, or learn one formula, the one on the left, and do that rearranging. Up to you, whatever you find easiest. Okay, you have got a few practice questions there. You know the drill. Pause it if you want to have a go. Answers are coming up. There are your answers. Mark them, and well done. Okay, let's finish with a little quiz. So pens at the ready, 10 multiple choice questions. So we're going to work out whether we need to use the sine or the cosine rule. So either just shout at your screen, sine or cosine, or write down a little S or C and see if you get them right. So first question. For this triangle, to find the missing value x, would we use the sine or cosine rule? What do we think? Sine rule. Okay, we've actually got two pairs of values. That's because we could find this missing angle, and then we'd have x and the angle and the 11 and the 11. Okay, we do have two values there. You just have to do a bit of work first, but that is a sine rule. Okay, next one. How would you find x? Sine rule or cosine rule? Yeah, that one's cosine rule, 3 sides and an angle. Remember, that's how we spot cosine rule. This one, sine or cosine? A tricky one. This one is sine again. Remember, you could find that third angle and then you've got your two pairs. Okay, a missing angle and the 11 and the x and the 25. This one, sine or cosine? Cosine, 3 lengths and an angle. Good spot. This one. Yeah, that's just your straightforward sine. You've got two pairs, x and 110 and 22 and 6. This one, sine or cosine? Cosine, good. We've got 3 sides and an angle. Next one, sine or cosine? Cosine, again, 3 sides and an angle. What about this one? Yeah, that's a nice sine rule one. You've got 2 pairs there of matching values. This one. Yeah, that's a sine rule. Again, 2 opposite pairs. And last one, sine or cosine? Yeah, that's a cosine rule. You've got the 3 lengths on the outside and you're trying to find one angle. Okay, super work there. There are some mixed practice questions here on combinations of the sine and cosine rule. So this is for if you need help spotting which one to use first and then working out which formula. I've put the formulae on the left there, but try and do it by memory. Try and learn those formulae and write them down every time you use them in a question. It's the best way to get them into memory. All right. Pause there if you want to have a go, but answers are coming up. There are your answers. And final ones, we've got some extension questions here. These are all taken from the brilliant Ben Cooper, who put together a mega PowerPoint on trig, so I can't take any credit for these, but just wanted to kind of give him a shout out for these questions because they're great. So pause if you want to have a go at those. They combine a few different areas of maths as well, but as a hint, they should all involve sine or cosine rule. Answers coming up. Okay, there you go. Pause and mark your work if you've done them. Brilliant. Well done today. I hope that was helpful, just going through those 3 non-right-angled rules for trigonometry. The annotated version will be available to download from my website. If you need further practice questions, you can find them on Corbett Maths. Videos 333 to 337. Next lesson on Wednesday at 5 p.m, we're going to be focusing on 3D Pythagoras and trigonometry. This is one that a lot of people struggle with because they struggle to visualise it. So I'm going to try and find some good little videos and little clips there that should help you with that because it is quite a tricky one to spot. So we'll see how we do with the digital lesson on that. All right, well done today. See you Wednesday.